Hello everyone, my name is Yashwardhan Joshi, and first of all I would like to express my gratitude towards Lalit Mohan Tiwari sir for giving me this golden opportunity in order to explore and explain this fascinating concept which is synchronous condenser. So first of all the thing is, what is it? What is a synchronous condenser? Basically it's a synchronous motor, but there must be something which distinguishes it from a regular synchronous motor. So the main thing is it works under a no load condition, or it rotates at a no load speed. So when it comes to motors, the mechanical movement is considered as the load. So when we free the machine, when we free the motor of the mechanical movement, the condition achieved is known as no load condition. So just for the sake of it, I would like to read the key points that I have written in under the heading Introduction. The first thing is, it is basically a synchronous motor, which is what I just said. And the special thing about it is, it works at a no load condition. As we know that every machine is made in order to fulfill a certain specific goal. So the question arises, why is it needed, or how can it be used? So let's say when we talk about transmission lines, it is usually used in order to increase the value of power factor in transmission lines. So you guys must be thinking that there must be some sort of problem with low power factor in transmission lines. So let me state this formula here. P equals to VI cos phi, wherein P is power, V equals to voltage, I equals to current, and cos phi is the power factor. So it is clearly visible that the current and the power factor are inversely proportional to each other. So let's say the value of power factor was to be low. This would result in the subsequent increase of the value of current, which will eventually lead to the increment of I square R, or current losses. And as we obviously know that losses and efficiency are inversely proportional to each other, this would lead to the subsequent decrement of efficiency, which is bad for us. And one more important thing that I would like to point out here is that the voltage regulation also increases, which is undesirable. As voltage regulation basically means it increases the difference between the terminal end voltage and the no load voltage, thus causing more losses. Again, bad for us. So the bottom line is, the more closer the value of voltage regulation is to zero, the better. So let us consider an example here where we have taken a three-phase supply where the power factor is low in this three-phase supply. So in order to overcome this problem, what we do is that we connect a synchronous motor at no load speed in a parallel connection to it. But there must be some sort of special condition, which is the reason why we are able to use this synchronous condenser in order to overcome this problem. So the special condition is that the field current rating inside the synchronous condenser must be maximum, which is very important. Because of it, it results in the machine entering an overexcitation state. It basically means that the current starts leading inside of the machine. And as we note that this is an ideal case of a capacitor because the current is leading the voltage inside of a machine. So this is the reason why a synchronous condenser is also known as a synchronous capacitor, which is what I have written here. That's why it's also called synchronous capacitor. And as I have mentioned this quite a few times earlier in this video, that there's no sort of load attached to the motor. This is the reason why the synchronous condenser is also known as the synchronous compensator. And in order to conclude my topic, I have written a very important note here, which I would like to read out loud. So, A synchronous condenser stabilizes the network by adding inertia and short circuit current to avoid large trips in case of faults. Which summarizes what I was trying to explain with the help of the example, that a synchronous condenser can be used in order to minimize losses and avoid faults of any kind. That concludes my topic, and I hope that you guys were able to understand it. I tried to put it out as nicely as I could and make it a fun learning experience, but my handwriting isn't that good, so I hope it was at least comprehensible. And have a good morning, afternoon, day, evening, or night, accordingly to whenever you are watching this. Thank you.